welcome back to Foley Systems. I'm Blake, and today we're talking about virtualization. Virtualization is everywhere from data centers to cloud computing, even in your home lab. But how does it work, and why is it such a game changer? Today we're breaking down virtualization, virtual machines, and their impact on modern computing. So let's dive in. Virtualization involves creating virtual versions of physical devices, enchanting efficiency and resource management. It allows for better utilization of hardware resources by maximizing performance and reducing waste. Virtualization simplifies management tasks by abstracting the complexities of physical hardware. Virtualization technology began in the 1960s with mainframe computers, allowing multiple users to access computing resources simultaneously. Significant advancements in hardware have improved virtualization capabilities, enabling efficient resource utilization and performance. Software development has also moved virtualization, leading to innovative solutions that support cloud computing and data centers. Server virtualization enables multiple virtual servers to operate on a single physical server, optimizing resource utilization and reducing costs. Desktop virtualization separates the desktop environment from the physical device, enabling access from various locations and devices. Application virtualization allows applications to run in isolated environments, improving co- compatibility and security. Network virtualization abstracts physical network components to create virtual networks, enchanting flexibility and scalability. Understanding the virtual machine. A physical a virtual machine creates a virtual environment that mimics a physical machine, allowing multiple OSs to run simultaneously. The virtual CPU is a key component that allocates processing power to the virtual machine, simulating a physical CPU's functionality. Memory and storage in a virtual machine enable the allocation of data and applications, functioning similarly to physical RAM and disk. Network interfaces allow virtual machines to communicate with each other and external networks, replicating physical networking capabilities. Role of a hypervisor. The hypervisor is a crucial for managing the execution of virtual machines on the host system, ensuring efficient resource allocation. Hypervisors allocate memory, CPU, and storage resources to each virtual machine, optimizing performance and efficiency. Each virtual machine operates independently without interference from others, thanks to the hypervisor's isolation mechanisms. Virtual machines allow for dynamic resource allocation, making it easier to respond to changing demands and workloads. Virtual machines enhance efficiency and scalability, enabling rapid deployment and management of resources as needed. Virtual machines can be easily created, modified, or deleted, providing significant advantages over traditional physical machines. Consolidating workloads help organizations save significantly on hardware costs by minimizing the number of physical servers. Fewer servers lead to reduced energy consumption, which not only lowers costs but also benefits the environment. Streamlining server infrastructure decreases maintenance expenses, allowing organizations to allocate resources more efficiently, effectively. Virtualization enabled dynamic allocation of resources, allowing organizations to adjust their infrastructure as needed by reducing the need for physical hardware. Virtualization leads to significant cost saving for deploying new services. Organizations can quickly deploy new services without the long lead times associated with physical infrastructure. Virtual machines offer a straightforward approach to backing up data, making recovery process more efficient, Effective disaster recovery strategies can be implemented through the use of virtual machines, ensuring quick restoration of services. Implementing robust backup solutions helps maintain data integrity and reduces the risk of data loss during disasters. There are two types of hypervisors, a type 1 and a type 2. Type 1 hypervisors run directly on the hardware, allowing for better performance and resource management. Type 2 hypervisors operate on top of an existing operating system, offering flexibility but potentially lowering performance due to the overhead. The main trade off between Type 1 and Type 2 hypervisors is performance versus flexibility, influencing choice based on use case. ESXi offers a lightweight architecture for enterprise virtualization. Proxmox combines KVM based virtualization and container based solutions. XN Server is an open source platform focused on server virtualization. Hyper-V integrates seamlessly with Windows environments for virtualization. VMware provides advanced virtualization solutions that enhance scalability, flexibility, and resource management for businesses of all sizes. Microsoft Hyper-V is a powerful virtualization platform that enables users to create and manage virtualization computing environments seamlessly. KVM, kernel based virtual machines, is an open source virtualization technology built into the Linux kernel, ideal for server virtualization. So, the popular hypervisor brands, VMware offers comprehensive virtualization solution for our diverse business needs. Microsoft Hyper-V integrates seamlessly with Windows, enchanting virtualization efficiency. KVM is a robust open source virtualization technology embedded in the Linux kernel. Proxmox combines KVM based virtualization with container solutions for flexibility. XN Server focuses on server virtualization with open source foundation. Containerization offers a lightweight alternative to traditional virtualization, reducing resource consumption and improving performance. Containers provide isolated environments for applications, ensuring consistency across different deployment stages. With containerization, deployment becomes faster and more efficient, enhancing the overall development workflow. Virtualization is essential for cloud computing, enabling scalable and flexible resource management in data centers. Cloud environments utilize virtual machines to allow users to deploy applications quickly and efficiently on demand. Virtual machine virtualization allows developers to create isolated environments for testing applications, minimizing conflicts with other software. By using virtualization, developers can streamline the development process, focusing on creating and testing application effectively. Creating isolated environments lead to more reliable results in application testing, ensuring software quality and performance. VDI, or Virtual Desktop Infrastructure, enables users to access their desktop environments from any location, facilitating remote work and flexibility. With VDI, data is stored centrally, which enhances security and reduces risks associated with data loss or theft. Organizations can reduce hardware costs and streamline management, leading to overall cost saving through VDI implementation. VM escape is a significant security risk that allows attackers to break out of a virtual environment, posing threats to host machines. Data breaches in virtualized environments can lead to unauthorized access to sensitive information, impacting organization security. Organizations should implement robust security measurements, including encryption, access controls, and regular audits to counteract virtualization risk. Edge computing allows data processing at the edge of the network, reducing latency, improving performance for applications. Hybrid, hybrid cloud environments combine public and private cloud solutions, providing flexibility and scalability for organizations. Organizations must evolve and adapt to trends like edge computing and hybrid cloud to stay competitive in the market. So, the importance of virtualization. Virtualization is crucial in modern computing, enable effective resource management and innovation across industries. Driving innovation through virtualization, organizations can innovate quickly by developing applications and services more effectively. The future trends. Understanding future trends in virtualization will help organizations stay competitive and effective in their operations. So we'll jump over to a demonstration of a hypervisor. So in this instance, we're going to use Hyper-V. But before we jump into that demonstration, let's first try to visualize what that PowerPoint was trying to tell us. So we'll open up here in Visio, and I'll show you a demonstration of what a virtual machine operates. So let's take this PC for instance. Well, this is just the physical host itself. This is running, let's say, Windows 10, for example. So Windows 10 as itself, well, it can act as a hypervisor if you install VMware Workstation or VirtualBox. But at that case, we'll be running a Type 2 hypervisor, which, for instance, let's see if we can find a good diagram photo. Let's just take another PC. We'll grab VM. So practically a layer 2 hypervisor. So this is going to be our layer 2. Our layer 2 hypervisor will run on top of the operating system. So let's say we went with VMware Workstation. And this right here, it could be another Windows machine or Ubuntu. But for that VM to get to the host, for this instance, Windows 10 resources, it's going to have to first go through the hypervisor, from the hypervisor to Windows 10, and then vice versa. Windows 10 to the hypervisor to the virtual machine. As you can see, that would create a huge performance impact. Well, we're adding an extra layer of data communication between the host and the virtual machine. Well, we don't want that. So, type 2 hypervisors are good for development, for a home lab, if you're going to deploy something to your server, or for enterprise. You could test something out on a type 2 hypervisor or layer 2. With a type 1 hypervisor, we kind of cut the middleman out. So it is now just direct access to the host. And for this instance, we're going to use ESXi as it's a popular solution. Right now, they're going through a little of a twist. I don't know how more popular they're going to be, but we'll see eventually in the future if they're still standing. But this here is a layer 1 hypervisor. What that means is there's no middleman. The VM's like, hey, I need this RAM allocation address. It'll say 0x21A. It'll ask for that memory address. And then once it asks for it, it will receive it instantly versus going through another layer. Say, hey, I need this. Okay, let me fetch it for you. Well, let's say the host is running Google Chrome, since that eats a lot of RAM. The best example I could do. Well, Windows has Chrome open. Well, now it's going to take a while to find that in the RAM because it has to search. versus when it's just ESXi in the virtual machine, it'd be like, hey, give me that memory address. Okay, here you go. It'll hand it straight back to the virtual machine. So, as an example, it's similar to this, your virtual OS and your thin app. Well, let's say you have your app. So let's don't do a thin app, let's do an app instead. Well, now that's going to sit on top of your virtual machine because the app is now standing between the OS, the physical virtual machine, and ESXi. Well, this is still going to process the memory at location 0x21A quicker versus having layer 2. But to show this a little bit better in a computer demonstration, we could take one of these computers and turn it to mini. So we could take this one computer and turn it to multiple computers. So for instance, we could have Windows on one computer. We could have, I'm on work with me. We could have Ubuntu. We could have a DNS over here. We could have Windows Server. We could also have a load balancer. All those could run from the single server. So Ubuntu could be hosting your website. Windows could just be a virtual editing machine. Your load balancer could load balance between your website or Windows Server ISS manager. Your DNS, of course, handle queries from your network. But virtualization is the most useful thing that has come into existence because before, without the advent of virtualization, you would have had to run a single server for each of these. So you would have had a total of 5 servers versus just having one for each individual application or OS or service you're going to use. But that's going to be all for today's demonstration. We'll have to do a Hyper-V demonstration in the next video. So whether you're an IT pro, a student, or just a tech enthusiast, virtualization is a must-know technology. Want to see a deep dive in hypervisors, Proxmox, or home lab setups? Let me know in the comments below. Please like and subscribe. And you guys have a very lovely day.